section of the physical geology textbook that I'm going to cover today is Chapter 3, Section 2, and can be found on pages 77 through 82. Please feel free to refer to the text for any clarifications. However, I'm going to try to be as clear and concise as possible. Below, you can see some of the most common mineral specimens ranging from calcite to quartz to tourmaline. There are many minerals that we are tragically unaware of, especially seeing as to how minerals are so vital to our everyday lives and play a huge role in our economy. The minerals below range in cleavage to surface to color. The world we know is constantly changing, bringing about destruction and creation, which is what makes it so unique. And with the creation of minerals, the world as we know it changed, and most would say for the better. We all know what minerals are, or do we? When looking at a rock like this one, which is pumice, there are some visible features. To name a few, it is light in color, very porous. These are the things that we can observe, but whether a substance is a mineral or not is not something that is observable to the naked human eye. You may have thought that pumice was a mineral when you first looked at it, but if you look closer, you might realize something very different. To get a closer look, let's first understand what a mineral is. A mineral is best defined by a specific group of scientists known as geologists. Their definition requires that for an object to be classified as a mineral, it must meet the following criteria. 1. It must be naturally occurring. 2. It must be an inorganic crystalline solid. 3. It must have a specific chemical structure. Should a substance meet all three of these criteria, it can be classified as a mineral. However, should it fail to meet even just one of the criteria, it is not considered a mineral. Fully understanding the criteria is the only way to classify minerals correctly, so let's do so a little bit more closely. The first criteria is pretty straightforward. It cannot be artificial and must be naturally occurring. So, let's say that you go shopping for a pair of earrings one day. You choose the earrings made out of cubic zirconia because they're cheaper than the real diamonds that you had originally come into the store to buy. This distinction is what disqualifies cubic zirconia from being a mineral. It can be ruled out as a mineral because it's man-made, which is why it is commonly referred to as fake diamonds. Fake because if it was real, it would have been made by nature, just like diamonds are. The second criteria, the substance must be an inorganic crystalline solid. This one is a little tricky, so let's break it down into a few key terms. The first term is inorganic. And, according to the textbook, in order for something to be qualified as inorganic, the compounds lack carbon derived from living matter. The second term is crystalline, and according to this textbook, in order for something to be qualified as crystalline, the minerals consist of atoms arranged in an orderly pattern. This orderly pattern gives the minerals a particular chemical composition. And the last term is solid. And according to the textbook, in order for something to be qualified as solid, particles in a solid are closely packed together. However, you can tell if something's a solid usually by just looking at it. The particles in other states of matter, such as liquid and gas, are not compact and have a lot more room to move around freely. This is what allows liquid to be so fluid and gases to be so airless. The last criteria is that the substance must have a specific chemical structure and formula, and we will understand this by breaking it down again into a few key terms. The first term is chemical structure, and this is expressed as a chemical formula. A chemical formula, according to the textbook, lists its component ions according to the proportion in which they occur in the mineral. Now that we have looked at all of the criteria more closely, remember that if a substance meets all of these criteria, then they are considered to be a mineral. But if they don't meet even one of the criteria, then they cannot be considered a mineral at all. But let's take a look at the substance mentioned earlier, pumice. How do we know if it's a mineral? Well, let's look back at the criteria. Is pumice naturally occurring? We know this is true because pumice is an igneous rock that forms from the cooling of certain types of lava that comes from volcanoes. But remember, in order for pumice to be a mineral, it must meet all of the criteria. So let's give it a check mark and move on to see if it qualifies. The next criteria deems that the substance must be an inorganic crystalline solid. And while pumice may be inorganic, It isn't able to have a crystalline structure due to the cooling process, which occurs so rapidly that the atoms don't have enough time to arrange themselves into a crystalline structure. Pretty cool, right? But we still have to put an X by it and disqualify it as a mineral, unfortunately. In order to provide a better understanding of the mineral criteria, let's look at the most common mineral in the world, feldspar, specifically labradorite. Not quartz, that's the second most common, and it is a common misconception that it is actually the most common mineral instead of feldspar. However, it is untrue. So, now, let us look back at the criteria so that we can evaluate labradorite's qualifications as a mineral. In compliance with the first criteria, is labradorite naturally occurring? According to geology.com, labradorite occurs in gneiss that has been produced through the metamorphism of labradorite, bearing igneous rocks. This qualifies it as a naturally occurring substance, so we can put a check mark next to it and move on to the next one. Is labradorite an inorganic crystalline solid? This is also true, and is closer to being a mineral than pumice, and now we have 2 check marks. Does labradorite have a specific chemical structure and formula? Yes, it does. Now we have 3 check marks and can categorize this substance as a mineral because it has met all 3 of the criteria. As mentioned earlier, feldspar is the most common mineral on Earth, with quartz as a very close second. Why is this so? According to the textbook, it is because minerals are combinations of elements, and the most common minerals are composed of elements that are the most abundant in Earth's crust, and we call these rock-forming minerals, and they can be commonly found in the Earth's crust. This chart contains some of the most very important rock-forming minerals. The most important thing to look at are the similarities in the composition, which is located in the column farthest to the right. If you go row by row, you can see some of the most common chemical formulas listed, and including are feldspar and silicate, which you can see in almost every single one. That concludes this review lecture. I hope you now have a better understanding of orderly expressions of matter, as this material is a building block for lessons later on in the semester. For clarifications again, please refer to Chapter 3, Section 2, found on pages 77 through 82 in the textbook. Thank you.